Oh, it's just abstract, just kind of random. It could be whatever you think it is.
Lots of birds.
Could be mountains.
Oh, gee, that's an interesting.
Oh, it could be a bird.
I can't tell whether it's minimalist or abstract.
Well, I don't know, but I'm playing around with oil paints, so
Yeah.
that's what you get.
Because abstracts are all like, it means whatever you want it to mean, and the minimalists are like, it's a painting.
Yeah.
So I can't tell which one.
All right. Well, let's talk about PA4.
Okay.
So PA4 has already been posted. And for PA4, you're going to make another game. You're going to make a game that will play 20 questions.
Oh.
So how many people here have played 20 questions? You can actually buy little toys that'll play it with you. So you know the basic setup, right? The user is going to think of something and the computer is going to try to guess what the user's thinking of. And it's going to do this by asking a series of yes/no questions, and the user will hopefully honestly respond yes or no, and it'll try to narrow down and figure out exactly what the user's got in mind. And we're going to build this around a decision tree, which is a binary tree, but it's not a binary search tree in the usual sense. It's a tree that we can store information in, and as we play the game, we're going to be traversing this tree. And when we get to a leaf node, we're going to have an answer. So let me show you a simple decision tree. So this is for somebody who's thinking of an object. So we have questions and answers. So most of our nodes are going to be questions. Leaf nodes will be answers. And the two children of each node we can think of as yes and no. So the first question the computer might ask is the thing you're thinking of hard? And if the user says yes, then it's going to say, okay, you must be thinking of a rock. And if it's not hard, then it's going to say, okay, you must be thinking of a pillow. So there's a 3-node tree that will read your mind and tell you exactly what you're thinking of by just asking you yes/no questions. All right, so somebody think of an object. Don't tell us what it is. Who wants to think of an object? All right. Is it hard? It's got to be yes or no.
Yes.
Yes, okay. It must be a rock. Is it a
That's not
rock?
question.
No, that's my answer now. I'm telling you what you're thinking of. You're thinking of a rock. Am I correct?
No.
No. Okay. We've been foiled. Okay, so the computer makes its prediction of what you're thinking of, and if that turns out to be what you were thinking of, if you had actually thought of a rock, you'd be amazed and think I could read your mind, and that's all great. But if the answer is wrong, here's what you do. You say, what were you thinking of?
That's not a yes no question.
And then you tell the program what you're thinking of. So what was it?
The document camera.
A document camera. Okay. So a doc camera. And then the computer will say, okay, please tell me a question for which a document camera, the answer would be yes, and a rock, the answer would be no. And then you're going to type in a question where yes means document camera, no means rock. So then you got to think up a question for which that's true. So think up a question where for a document camera the answer is yes, for a rock the answer is no, and tell me what the question is.
Can you find it in outer space? Wait, no.
That's probably a safe one.
What?
Well, you can put rocks in outer space, though.
Yeah, but not document cameras.
There you go. Okay. How do we know that we can't find document cameras in space?
Well, I can't find them. I don't know where Best Buy is in Andromeda. Should we go with that one?
Is it man-made?
Okay. So is it human made? And if the answer is yes, then it's a document camera. And if the answer is no, then it's a rock. So we took our answer, which was incorrect, and we replaced it with a question, and we put 2 children off of that question. The no answer is the old answer that we guessed that was wrong. The yes answer is the answer that was correct. And now we can play the game again. So somebody else think of an object. Okay, is it hard?
Yes.
Okay, is it human made?
Yes.
Okay, I know exactly what you're thinking of. You're thinking of a document camera, aren't you?
No.
No. Okay, we've been foiled again. So what were you thinking of?
A car.
A car. Okay, so give me a question where yes means a car and no means a document camera.
Can it move?
Okay, so again, we replace that wrong answer with a question. We put the wrong answer, in this case, on the no branch. And we put the yes answer, leading to what you were thinking of. And we're building our decision tree as we go. So now, if you're thinking of a rock or a pillow or a document camera or a car, we're going to be able to guess it. And it might take 3 questions.
Will we have to worry about balance or anything like that?
No, so ideally this would be balanced, but we're not going to balance it. So if you ask the questions in just the right way, you can make the performance really bad. But across a random sampling, right, this will do pretty well. So your goal is the following. You're going to write the code that will take a decision tree and play the game based on it. And playing the game is pretty easy. You start at the root and you ask a question and you follow the link for the yes or the no, and you keep going till you get to a leaf node, and then your program just says, okay, I know what you're thinking of, and it tells you what the leaf node is. And if that's incorrect, then you get a new question, replace that leaf node with a question, add 2 branches, play again. So playing the game is pretty straightforward. It's really just following nodes based on the user's response. Yes?
So we don't have to actually, like if they said no, we don't have to find the second closest from what they gave us?
No. You mean if you're done and you guessed and it was wrong?
Yeah.
No. You're just going to add a new.
So if they
Small tree.
accidentally hit the wrong button.
If they mess up, then they'll corrupt your database. That's okay. Because you're gonna have noise in there. So, but you could have like an abort button, you know, or an abort command or something, so that if the person knows they did something wrong and they say no, forget everything I said, you can like kick out without actually corrupting your tree.
That must be how that one Genie program on the
Yeah. You had your hand up?
Yeah. So what if like for the is it handmade? What if you had said if you can find it in space, and then right after that, like if it's yes or if it's a no for the document camera, if you could put that same question again.
Yeah, the same question might appear multiple places.
Okay.
That's okay.
You don't want us to do anything?
No, we're not going to be fancy about this. We're not going to worry about how we might optimize it or eliminate redundancies or things. We're going to take the very straightforward, right? And it's really just follow it down, get to a leaf, announce your answer if it's wrong, get a discriminating question, pop it there, add your 2 children, and you're done. And you had your hand up?
Yeah, I forgot what I was gonna say though.
Okay, let me know when you think of it. All right, so that's your first goal is you're going to play this game, okay, and you're going to update this tree. You're also going to keep this tree on a file on your system. So when you, that was your question?
Yeah.
Okay, so when you first start playing, you're going to read in this tree from a file, and then every time that you update it, you're going to write it out to that file. So it's going to learn across multiple runs, right? You come back to this later and you run the game, and it should start with this augmented decision tree, and as you play it, it'll keep adding to it, and that'll always be available. So that's your second goal, is be able to write this out to disk and read it back in from disk at the beginning. And that's really kind of the sum of the hard requirements. You're not restricted to 20 questions, that's just the name of the game.
Oh.
But yeah, I know, it's a marketing thing. So you can play until you get to a leaf node. Binary tree, 2 pieces, begin the root, ask the question, get to the end. If it's correct, no action necessary. If it's wrong, get a discriminating question. Write the tree out to a file, read it back in from the file. Okay, additional requirements, make sure your code is well commented. I haven't looked at any PA3s yet, but I'm anticipating lots of beautiful comments, so keep that up. And this is one where you have artistic license to design this however you like. Okay, you can do this on the command line if you like, that's great. You can print everything out and the person can type Y or N and hit enter, or yes or no and hit enter, and it can have a dialogue through the terminal session. And if you want to go that route, that's great. You can develop this all on the Linux server if you like, or your own system, and then just bundle it into an Eclipse export when you're done. But if you want to add graphical elements, if you want to have a window where you can click the yes or no button and it will show you the question in a text box, or maybe it'll let you scroll back and look at the past questions or whatever you like, right? You can do what you like with this as far as the design. And if you're interested in doing more with Swing and widgets and GUIs, right, this is a good opportunity to get into that. Modularize, et cetera, as usual, breaking it into pieces. We'll look at that in a second. Yeah,
So when we're turning this in, we don't have to supply the file, right?
you do not have to supply the file. So yeah, and so I should have this in here. I'm looking for the word database. There we go. So I want you to define a string whose name is database and set that equal to the file name that it's reading and writing from and to. Okay, so don't hardwire a path in your code anywhere except in this one assignment of this variable named database. So say something like database equals blah, and then when you want to open the file, open it from that string database. And then I can change that and I'll point to my own file to work with. So something like this.
Are you specifying, why would we have to traverse the tree in a program like this?
That's how you play the game. Oh, but you're seeing that NLR?
Yeah.
Okay, so so we okay up to this point? So this has to do with writing out to the file and reading in from the file.
Okay.
Okay.
So you're importing into your system, using the file to play the game.
Yeah, you're gonna pull it into a tree structure, which you're going to define. Okay, so don't use a tree class. You're gonna make your own tree, and your nodes are gonna basically be a string of text. You can add a flag saying whether it's a question or an answer, or you can use the fact that answers have no children, questions have 2 children. So you can figure it out that way. But let's talk about how you put this into a file. So the file format is pairs of lines for each node. So a Q colon or an A colon to indicate a question or an answer, followed by the text of what that node should be. So let's work with our Rock and Pillow database. So here's a question. Is it hard? Here's an answer. It's a rock. Here's an answer. It's a pillow. Okay, so that would be a 6-line file for this initial tree that we had. Is it hard? Is it a rock? Is it a pillow? When you make a change to this decision tree, don't try to manually touch up this file. Okay? Make a change to the decision tree, and then we're just going to rewrite the entire file from the decision tree. And that's going to be a lot easier than trying to understand what order things go in this file itself. Okay, that's an important detail. So in the beginning of the game, we're just going to read this file, build a tree. At the end of the game, we're going to update the tree, and then we're just going to rewrite that file from the tree. Okay, so the only thing we're doing with this file is reading it in to build a decision tree or recreating it from the decision tree. We don't actually go in and sort of edit individual lines in here. It can be done, but it's way harder. So let me show you how to write a file. Just do a node left right traversal, pre-order. And if you do your writing in this way, it makes it really easy to read back in and build a tree. So let's see what we get if we traverse this tree pre-order. So we'll get a question, is it hard? And let's just go down to this part where we had a document camera and a rock. So question, is it hard? That's the node. And then we want to traverse the left tree, node left right. So the node of this tree is another question, which says, is it human made? And then we traverse to the left, and over here we had an answer, which was a document camera. And then on the right we had an answer, which was a rock. So we traverse the node of this tree, we traverse the left subtree, and now we traverse the right subtree, which is an answer saying there's a pillow. So this would be the file corresponding to this second version of the tree that we had. Okay, before we replaced doccam with a question. So it's not totally immediately clear from looking at this file that this is the tree structure we have. Okay, and certainly from here to here it's not immediately clear what happened. But we're not going to try to go from here to here, right? We're going from here to this little tree. We're playing the game, adding another node down here, and then going from this into this file. All right, so how do we process this file? Do it?
It sounds pretty easy. You just do node left, right, and reach 2 answers.
Yeah, we do node left, right. Your answers will always be in pairs, ultimately. So let's write a routine. This is going to return a decision tree. And I'm just going to call it ingest. And you may want to pass it a scanner object, or you may make that global or something. Okay, but the basic structure of this method is, it's called ingest. It reads from the file and it returns a decision tree. So what does this do? Read the first 2 lines from the file. The first line is the type of information stored in the next line, which I'm calling text. Okay, so I'll read type. That's going to tell me I've got either a question or an answer, and then I'm going to read the actual text. Bless you. All right, so if the type that I read was an answer, I know that I'm at a point in the file where I have a leaf node. And I'm going to return a very small tree containing just that text. So I'm going to return a tree that looks like that, a tree with a single node in it, whose text is equal to whatever that text is that I read. Otherwise, the type's not A, the type has got to be Q. So I don't really need an if statement there. But this is what's going to happen if the type was Q, if I was at a question point. So I've read a question, I've read the text. So now I'm going to do the following. I'm going to define a D tree called yes, and I'm going to recursively call ingest and say read in a tree from the file at the current point, and whatever it returns, I'm going to call that yes. And then I'm going to make another D tree called no, and I'm going to say go ahead and ingest from the file, and whatever tree ingest returns, that's going to be my tree called no. And then I'm going to return a node containing text with a left subchild, which is yes, and a right subchild, which is no. This is like visual pseudocode now. Right, so you create a D tree, you set its root equal to a node that contains this text, you set its left child to whatever this tree was, yes, and you set its right child to no, but I'm just showing it visually here, right? So if we read an answer from the file, we just return a single node. If we read a question, we return a tree whose root contains the text that we just read, whose left child is whatever our first call to ingest returns, and whose right child is whatever the second call to ingest returns. And if you play around with a file and you make some trees and you don't get lost in the recursion, you can convince yourself that this will give you the same decision tree that you had when you wrote this file. Okay.
I think it's fun to, 'cause if you add an extra answer, it'll just cut that out. Or I guess if you don't have enough answers, it'll break.
It'll break if this is corrupt. If you don't have enough stuff, or if it's in the wrong order, it will break. If you have extra stuff, that extra stuff will get unread.
Yeah.
Because this will end exactly at the end of the file if everything is the way it should be. So this is only one level of recursion. Let's just run through this for this particular tree, and let's make sure we get back our decision tree. So we're going to read the type, which is a question, and we're going to read the text, which says, is it hard? Okay, if the type is an answer, no, it's not, so we're not going to do this. The type is a question, so we're going to call ingest recursively. So I'll switch to green. Here's our green call to ingest, which is going to read a type from the file, which is Q, and a piece of text, which is it man-made? And the type is not A, so it's going to come down here. The type is Q, and it's going to call ingest again recursively. So we'll switch to purple, so we're calling ingest again. And it's going to read a type and a text, and it's going to say, is the type A? And it is. So it's going to return a node which contains the text document cam. So the return from ingest is this single node which says doccam. And now we're going to call ingest again. So we're calling ingest down here, and we're going to read in rock, which is an answer. So ingest will say, is the type A? Yes. It'll return a node containing rock. So no is this single node. And now we're going to put these together and make a tree with 3 entries. The first entry is going to be the text that we originally read from our green ingest, so that was, is it human made? And the yes node will be doccam. And the no node will be rock. And that's going to be the return from this purple call to ingest. Okay, so this is what we got back from this call. And now we're going to call ingest again. So this is the yes node. And now we're going to call ingest again, which is going to read an answer, which is a pillow. And that's going to return pillow. And this one, the yes node, was this thing that we got back. And now we're going to create a new tree, and we're in our first call to ingest. So the text is going to be this first question that we read. Is it hard? And the yes answer will be the yes node, and the no answer will be the pillow. And that's actually our original tree. So is it hard? No, it's a pillow. Yes. Is it human made? Yes, it's a document camera. No, it's a rock. So writing it is very straightforward. It's just a pre-order traversal. Okay, you've been doing these most of your life, at least since last year. And then the ingest, if you do it like this, it works. And this is one of these things where you have to play around with it on paper and make a sample database and convince yourself that this recursion actually makes sense. Up to a point. Once you decide that this is correct, right, then you basically forget about the icky details of the recursion and you just code this, right? And you believe that if you do these recursive calls to ingest to build the left and right subtrees, you're going to end up with the correct tree to return. But then it's this kind of putting blinders on thing, where you say, I'm not going to think about going down the rabbit hole, I'm just going to write code to implement this. So there's a back and forth there. But you can do this independent of the rest of the program, right? You can just write something like an ingest method that reads from a file, builds a tree, and then takes a tree and writes to a file. And you can thoroughly develop this without even worrying about modifying the decision tree, right? If you can take a file like this, build a decision tree, and then write that out to a second file, and that second file looks exactly like the first file, then you know that you're doing everything correctly. All right, questions on that? So I suggest not starting with an empty tree, because empty trees are kind of edge cases. Start with a 3-node tree. Like, is it hard? Yes, it's a rock. No, it's a pillow, or something like that.
You could start with a 1-node tree.
You can start with a 1-node tree.
Is it
It's
rock?
still a bit of an edge case. And you can hardwire that in your code if you like, right? Or you can assume that there's always a file that contains at least one question.
You can easily say, like, if the file is empty, just ask, is it a rock, or something like that.
Yeah.
Start with that.
Yeah.
That would be fun.
All right, so here's our 3-line decision tree file. Is it hard? Yes, it's a rock. No, it's a pillow. And I'm just calling this 20q.txt. And so I've got my database, which points to 20q.txt. So let's go ahead and run this. So it says, hello, shall we play a game? Think of an object, and I'll try to guess what you're thinking of. All right. So who wants to think of an object? Okay. Is it hard?
No.
No. Okay, I've got it. Is it a pillow?
No.
No. Okay. So you stumped the mighty computer. So what were you thinking of?
I was thinking of a giraffe.
A what?
A giraffe.
A giraffe. Okay, please tell me a yes/no question, where yes means a giraffe and no means a pillow.
Is it an animal?
Okay, so is it an animal? All right, so we play again. Think of an object. Is it hard? Well, let's suppose you're thinking of a giraffe. Okay, so is it hard? No. Is it an animal? Yes. It must be a giraffe. So we can say yes. Okay, is it hard? No. Is it an animal? No. It must be a pillow. And is it hard? Yes. It must be a rock. All right, so think of a new object, someone.
So, did we had to specify that no was the old one, yes?
You can do it whichever way you like.
Okay,
Just make sure it's clear to the user, because that's what I'm going to follow
sure.
when I play it. Oh, but let's look at the file. Right, so the file's been augmented, and the yes side didn't change, but the no side became a question with 2 answers. All right, let's think of a new object. Got one? All right, is it hard? No. Is it an animal? No. Is it a pillow? Okay. So what were you thinking of? An orange. All right. Think of a question for which yes means an orange and no means a pillow. Is it a citrus? All right.
It's an interesting thing, like, you can't quite measure specificity. But
Yeah.
if you had broad questions at the front, then it becomes a more balanced tree.
Yes. So if you wanted to train this to do a good job at 20 questions, you should try exactly that strategy.
Only or similar to, like, how a computer know how specific a question is.
Yeah, yeah. Because you could just say, you know, is it a giraffe?
Yeah,
And that's
that's your question.
obviously going to give you the decision that you want, but it's not going to pare down the search space. So 20 questions, how big is a search space? How many different objects can you differentiate theoretically?
And 20 questions?
Infinite?
No, because
Yeah.
there's only 20 questions.
There's only 20
Bottom.
questions.
Yeah, but you
There's-
can choose any question to ask.
Oh, no, nothing, I think.
But how
it's-
many can you correctly identify with 20 questions?
Like, I'm thinking at the top it's
2 to
1,
20.
when it goes 2,
Yeah.
it doubles each time.
Yeah, it doubles each time, so
at
like
the
Taylor
bottom,
said.
It's going to double 20 times.
Yeah.
So it's 2 to the power
2 to the
20 at
20.
the bottom.
Yep.
And then
So
plus
what's-
2
what's
the
2 to
power
the 20?
19. No.
Too big to count.
What's 2 to the 10?
Well, is there an easy way to, like?
Yes. Well, you got to memorize 2 to the 10, but what's 2 to the 10?
Oh, isn't that 10 for 1?
Yeah, it's about a K. So 2 to the 10, roughly 1,000. 2 to the 20, roughly the square of 1,000 is a million. Right? 2 to the 30 is a billion. 2 to the 40 is a trillion. 2 to the 50th is whatever comes after
It's
that,
like-
squillion or something.
2 to the 20 plus 2 to the 19.
It's not actually. Your answers are all on the bottom layer there,
That's true.
or wherever the leaves are.
Okay.
But if you were adding those, what would you end up with?
Well, I'm not gonna try that right now.
Yeah. So when you add all of those things up to 2 to the 20th, you get roughly 2 to the 21st, but there's a minus 1.
Oh, yeah. That's a good point. I didn't think of
So,
it.
based on the questions, it also like determines how balanced the tree's gonna be, right? Because if Andrew had said like, is it a fruit or something like that,
Mm-hmm.
it's like a lot prouder than saying if it's a citrus. Because
Right.
now, if it's not a citrus, then it's gonna go into the wherever the pillow is,
Mhm.
and make a new category for like
Right, right.
a fruit or something.
Yeah. So ideally, with each question, you're paring your search space in half, right? So this is why you start off with like, I don't know, is it alive or not? If half the things in the universe are animals and half of them aren't or something. And so each question is supposed to sort of cut your space by half and then leave you with one thing after login guesses. So you can develop this and build up your database, and you can swap your database with classmates, right, and play each other's game like that. And it's not the same as swapping code, okay? Swapping the database file that you build is perfectly fine. And here's the thing, if you write your code and you build a database file and you're adding it and augmenting it, and two of your friends do that, and you all swap your files and it all works perfectly fine, chances are you're doing everything perfectly right, right? The other possibility is you're all doing something wrong, but you're doing it wrong in exactly the same way. And that's not very likely. And the more people you test this with, right, the more you're gonna know that this is probably doing the right thing.
So we have to implement our database this way?
Yes, you have to, because I'm gonna use my own databases. And I'm going to give you a database that you can play with, which is called 20QBig. And this is 40,000 lines, so 20,000 nodes. And it's got lots of good stuff in here.
I wasn't thinking of anything, I was just hitting all yes.
Yes. Or a shape-shifting alkaloid.
Because if you're going to do this graphically, you usually have a bit in the corner that's like, here are some of the answers you've asked, or so if you just spam the thing, you can go, okay, there's nothing here.
Yeah,
And
yeah.
You can see what I did.
Mm-hmm.
So I can do something.
Yeah. So you can take this database and wire it in just by changing what you point to. So if I point to 20QBig, we can play against this. Oh, let me stop this. All right, so who wants to think of an object now? And this will be a real game. I know you're afraid because it's going to read your thoughts.
Okay.
Got something?
Yeah.
I think it's got to be an animal, actually.
Oh.
I think this database is animals.
Sure. Okay, let's do a bear.
No, don't tell us what it is.
Okay, I'll
Think of a new animal.
something else. Yes.
Okay, does it fly?
Yes.
Yes. Does it have feathers?
Okay, yes.
Yes.
I'm like, what doesn't have feathers?
Does it sometimes live in water?
No.
No.
Do you know that for sure?
Does it like to bury its head in the sand?
No.
We know what that's for. Is it a bird?
Yes.
Is it found around the beach?
No.
Can it talk?
No.
Does its wings beat very fast? Do its wings beat very fast?
No.
No.
That's a rock.
Is it related to eagles and hawks?
Yes.
Yes. Is it extinct?
No.
I think we're at 10 questions. Is it the national symbol of the United States of America?
Yes.
Yes. Does it have a brown head?
No.
Is it white with big eyes?
Yes.
Is it a large bird?
Yes.
That's a little
I think
subjective.
we're right to the question at this point.
Okay, I've got it. Is it a bald eagle?
Yeah.
Yes.
Now I want to see the tree. What's it say when you say it has a brown head? Because I don't know if there's a symbol of the United States of America. It's like the Eagles. It's brown. Turkey. I guess it could have been a turkey.
That was going to be the symbol of the United States. That's what Franklin wanted.
Yeah.
But it says the national symbol. So you can look at the database, but
Okay. Is it?
either the national symbol of the United States.
If you say yes, yes.
Does it have a brown head?
Snow owl. So if you say yes to having a brown head, it just says eagle. Which is What's mean eagles like?
Yeah, if you say yes, it's going to say eagle. If you say no, it's going to say is it white with big eyes. And if you say yes, it's a large bird. If you say no, it's going to say bald eagle. So yeah, so there's multiplicities of answers in here, right? Because there's different branches that'll get you there, and this is crowdsourced, right?
Okay.
So depending on what somebody thinks is a large bird or not, you may get noise in here.
I was just thinking about the fast wings. It's like I think it's talking about a hummingbird.
Yeah, or a
But,
fly
I
or
mean,
something.
It does fly up pretty
Yeah,
fast.
yeah.
for hummingbirds.
Faster than I can. All right, so that's another option. I'm going to post these files under /temp. And I don't know if you're going to need a different version for Windows versus Linux because of the control M's at the end. So I'm going to post both, but you can see if either or both work for your code. So that's another way you can play with this once you've got your code rolling and you want to have fun with it. So questions about this?
I have a lot of questions, but I don't think they're overall.
You can ask 20 questions about this now.
It's like I'm just thinking of like if I wanted to have this like pull from the internet, I wonder if that's possible.
Yeah. So, and there's sites like that out here where people can go to a website and play this, and it'll build a database.
If I was stumped, could I like go if I wanted to build a database, maybe from scratch, maybe I could write a program to like fish through Wikipedia or something. That would
So here's a crude genie from years ago, right? You can go to Google and you can type in a question and put the word yes or is true or something like that in there, and then do the same thing but put in the words is false, and you can count the number of hits, and whichever one has more hits, decide that's what the answer is, that's what the truth is, right? So you can kill
Do you know if
hours
there's
like
a
that.
Java plugin for that?
Say what?
A Java plugin for searching the internet?
There's a class called URL that you can use to connect to a web page, for example.
I imagine that would
pull
be
down.
hard to plug into Google because you could do.
Yeah, except it's really straightforward with a straight HTTP connection like to port 80. When it's HTTPS, it starts getting a little funky.
You can bypass all that stuff with Python though.
Oh yeah.
There's some really cool libraries for doing that.
Yeah. And you can run Linux code or system code from Java, right? You can say execute such and such a command and grab its output. So there's all kinds of ways you could tap into this. And that might be interesting. Just make a Twitter account and take whatever people say is like truth and build a decision tree based on it. Maybe that will tell us the answer to everything.
Well, that just makes me think about the AI that they tried to plug into.
Yeah, exactly.
That went well.
I had a student do that for a service learning project one year. He was making a conversation program, and you would just talk to it, and it would try to learn phrases that you used and ways that you build sentences and carry on conversations with you. And he was demonstrating this at the final presentation in June, and it was working pretty well. And he took off to like go get a drink from the bookstore, and he came back 10 minutes later, and this poor thing had like totally changed its personality. Somebody had taught it to swear and all this other stuff, and so yeah, that's good possibilities. All right. Anything else on the instructions? Pre-order traversal, initial database. Yes.
I assume there's no category like selection.
You can specify if you decide you're. I mean, it doesn't have to be, right? It would depend on the database.
Yeah.
So, you could say something like, think of an animal, but a person could still think of an object or something. But there's nothing in the code that binds you to a particular category. And you can use, scanners, buffered writers, print writers. We got to talk about writers still, and all that stuff. But the tree code should be your own. Okay, so we'll talk about, we'll go through some tree examples next week. but it's no harder than a linked list, right? Have a tree node which has data and a pair of pointers, and have a tree which contains a root, which is initially null, and when you add things to it, you just set the root to be whatever your first node is, and you build from there. All right, so next week we will talk about trees. We'll go through some implementations of trees in Java. I'm also going to talk about regular expressions because this came up in yesterday's afternoon class. There's a good regex class you can use to create a regular expression and then compile it and then use it against strings to do pattern matching to pull things out of strings and so on. And that's useful enough that I'll want to go through and just sort of look at that for a little bit. And then we're going to go back and we're going to do red-black trees. And then I want to talk about something called Huffman encoding. It's a compression scheme, and this is a good place for it. And then we'll go on and get back into some more Java type things. So we're still kind of on the data structure side of things right now. And we'll also talk about Lab 4 on Monday, which is adding a push button to your Raspberry Pi so you can detect button presses, and debouncing the switch in software. So, because mechanical switches generate lots of button presses each time you press the button. So we'll debounce in software, and that's a good technique to know. All right, that's all I got. I will see you tomorrow if you like, otherwise next week.